Okay. So learning unit 2 is about stoichiometric calculation. So what does it mean by stoichiometric? Stoichiometric ini maksudnya balance. Okay, so in chemical reaction, we have the reactant side, we have the product side. Okay, selalunya macam ni. Kita ada reactant, okay, product. Okay, so stoichiometric means sebelah sini dengan sebelah sini have to be balanced. Kalau reactant 2, then product has to be 2. Itu maksud stoichiometric. Okay. So these are the learning objectives that you should be able to accomplish. Okay. Awak kena pandai explain, kena pandai hitung, okay, molarity, formality, normality and other units of concentration. So we have covered this slightly, okay, a slight introduction of this in learning unit 1, okay. Explaining dilution, okay, and then solve problem related to dilution, okay, and then solving problem using the stoichiometric approach. Okay, let us move on to the concentration of solution. So behavior of solution will depend on the compound itself and how much it is present. Okay, and that will indicate its concentration. Okay, for example, 0.1 molar HCl, hydrochloric acid, will behave differently with 1 molar hydrochloric acid. Okay. So this is both in aqueous. Okay, maknanya involve water, the preparation of this solution. So this will be more concentrated compared to this. Okay, so it will behave differently. Although the component are the same, still hydrochloric acid. Okay, but because of different in terms of concentration, they will behave differently. Okay. So next point, two solutions can contain the same compound but behave differently because of the proportion of the compound are different. Okay, for example, if I put, let's say, H2O will behave differently with H2O2. Okay, you know what H2O is? Tahu tak apa H2O?
Water.
Yes, water. Okay, so this is water. This one is peroxide. Both have hydrogen, both have oxygen. Okay, but this one, the proportion is different. It has 2 oxygen, additional 1. Okay, so these will behave differently now. Okay, so water considered as safe, but peroxide no. Okay, so because of the proportion, it leads to be different behavior of solution. Okay, faham? Boleh follow setakat ni?
Yes, boleh.
Boleh. Okay, good. Alright.
Boleh, madam.
Okay, good. Okay, next we move on to SI unit for chemical quantity, which is mole. Okay, the mole. Okay, so mole is also called Avogadro number. Okay, so I'm sure you have come across this Avogadro number, 6.022 times 10^23. Okay, so mole is defined as the number of carbon atom in exactly 12 gram of carbon-12. Now, why carbon? Okay, why carbon? Not other element. Do you know predictable? Tahu tak predictable tu apa? Tahu jadual berkala?
Yes, tahu.
Tahu?
Yes.
Okay. Yang ada all the elements that exist, okay, on the earth. Ada hydrogen, lithium, beryllium, okay, potassium, and many more. Okay, hundreds of them. Okay, more than 100. Okay, so why of all these elements, carbon-12? Okay, because isotope carbon-12 will have exactly 12 gram. Dia tepat. Okay, tepat. Dia carbon-12 punya atomic mass number dia punya mass pun 12 gram. Okay, that's why this is chosen. Okay, compared to yang lain, dia punya isotop lain, the mass pun different. Okay, so they have to use the same exact number. That's why carbon 12 is chosen. Okay. So what is the formula weight for water? H2O. Okay. So if you look at the periodic table, okay, hydrogen in water molecule have 2. Oxygen atom have 1. Okay, so we have to calculate the atomic mass number for total of these 2 hydrogen and also 1 oxygen. Okay, so 2 atom of hydrogen, the atomic mass number of hydrogen is 1 for every atom. So therefore total is 2 AMU, atomic mass number. And then for oxygen, if you refer to periodic table, 16 AMU, atomic mass number for every atom. So 16. So therefore the formula weight for water, okay, for H2O would be total of 2 plus 16, which is 18 atomic mass number, mass unit for the formula of H2O. Okay, so we report the molar mass. Kalau ini formula weight, molar mass 18 grams per mole. Okay, we use gram per mole. Okay, so ini basic je. Okay, so the concentration, okay, unit for concentration, the most general definition is the amount of solute, okay, in amount of solution. So you see the square bracket here, it refers to concentration. Okay. Now the most common unit used by chemists is molarity. Okay, so you will see this unit throughout this semester. Okay, molarity. Okay, or abbreviate by the letter, big letter, capital M. Okay, so defined by mole of solute per liter of solution. Okay, for example, if I report 1 molar solution, it means it has 1 mole of solute in every 1 liter of solution. Okay, okay. So if you see M, it's the same as mole per liter. Okay. Now, next we move on to how to prepare a 1 molar solution. Okay, for example, we want to prepare 1 liter of 1 molar sodium chloride salt solution. Okay, yang awak biasa makan kat dapur tu, garam. Okay, table salt, sodium chloride. So we need to prepare this. How to prepare 1 liter? Concentration dia 1 molar. Okay, so by definition, 1 molar ni, mole per liter, means 1 mole of sodium chloride in 1 liter of solution. Okay, 1 liter. Okay, so go back to the periodic table. Okay, the periodic table will tell you the atomic mass number of sodium and the atomic mass number of chlorine. Okay, the atomic mass number of sodium is roughly 23. Okay, gram per mole. Okay, chlorine is 35.5 gram. So bila awak tambah 35.5 dengan 23 gram per mole, okay, you get 58.5 gram. So that's why you need to weigh 58.5 gram of sodium chloride and put it in 1 liter of water. It will give you 1 molar. Okay, very simple. So the formula that you need to memorize, okay. Okay, molarity is mole per liter. Awak kena hafal ni. And then satu lagi formula awak kena hafal, how to get mole. Mole is abbreviate as small letter M. N, sorry. N is mass, okay, over molar mass. Okay. So yang ni yang saya hitung kat atas ni tadi. Ha ni. molar mass. Okay, formula weight tadi. Okay. So it become 58.5 tadi kan. Gram per mol. And kita nak tadi 1 mol kan ni. 1 mol. 1 mol. Okay, so ini darab ini dapatlah mass. That's why awak kena timbang 58.5 gram. Okay. Mol ni kita potong lah. So tinggallah unit gram. Okay. So dua formula ni awak kena hafal. Molarity dengan number of mol n. Okay. So far okay?
Okay.
Okay, so let's
Yes,
move
okay.
on. Okay, example number 1. Okay, what is the molar of sodium chloride concentration if you have 0.5 mol of sodium chloride in 1 liter? Macam mana nak jawab soalan ni? Macam mana nak jawab soalan ni? Saya teringat Yuga tadi. Yuga? Yuga, macam mana Yuga? Awak ada mic tak?
Ada.
Okay. So, macam mana Yuga? Tengok soalan nak apa? Soalan nak molar. So, maknanya we go to
Nak
the...
molar.
Ini rumus ni. Mol per liter. Dia nak ni.
Divide.
Macam mana? Apa yang bahagi apa?
0.5 divide 1 liter.
Okay. So, jawapannya? Jawapannya jadi? 0.5 mol per liter lah. Okay. Ataupun molar lah. Okay. Very simple. Okay. That's why I told you just now, you have to memorize that two formula. Okay. Senang nak jawab soalan yang berkaitan dengan molarity. Okay. Okay, second question. What is the molar sodium chloride concentration if you have 0.5 mol in 0.5 liter? Siapa boleh jawab ni? Dia nak volunteer? Jawab.
Bukan divide saja kan doktor?
Yes, divide saja. Apa yang divide saja tu? Which one bagi apa?
0.5 mol divide by 0.5 liter.
Okay, dapat?
Yes, then we get 1 molar.
1 molar. Okay, 1 mol per liter. Okay, betul. Alright. How about this? So what is the molar sodium chloride concentration? Again, kita nak cari M. If you have 10 gram of sodium chloride in 1 liter of solution. Macam mana nak jawab soalan ni? Given molar mass. Molar mass dah diberi. So, maknanya ini tadi molar mass, molecular weight. So, macam mana nak jawab soalan ni? Dia nak molar. So, means M juga. Okay. So, mol per liter. Apa maklumat yang diberi dalam soalan? What are the information given in the question?
The mass.
The mass. Mass is given. Now, how you want to convert this mass so that you get mole?
Divide by mole of the NaCl.
Remember the other formula that I asked you to memorize? N,
Yes.
which is mass over molar mass, kan?
Yes.
N is representing number of mole. Okay, kita nak ni supaya dapat masuk sini. So mass is given 10 gram kan? So 10 gram. So divide with the molar mass which is 58.5 gram per mole. Dapatlah mole dia. Dah dapat mol, masuk sini. Okay, and then given 1 liter, masuk je 1 liter. So dapatlah molarity. So tengok apa jawapan dia. Okay, so dapatlah 0.17 molar. Okay, boleh?
Boleh.
Alright, good. Okay, moving on to the next example. Okay, so the question is asking for moles, maknanya N ni. Okay, present in 2.5 liter or 0.1 molar HCl. Okay, so how are you going to solve this question? Macam mana nak solve soalan ni? Mula-mula kita buat apa? What do we do first?
Using the molarity formula.
Molarity formula to get what? What can we get from here?
We can input the liter and the molarity.
Okay, so we can put the liter, we can put the molarity. So we'll get
2.5.
mol. Okay, mol. Very simple. Okay, so the answer is 0.25 mol. Okay. How about this? What volume? Ni lain pula sekali. Volume. Okay. What volume of 0.1 molar sodium hydroxide solution needed to provide 0.5 mole of sodium hydroxide? Okay, ni for this question kita ada rumus ketiga pula. Okay, rumus ketiga kalau tadi N number of mole, okay, mass over volume. Okay, kalau sekarang kita nak cari mol, mana ada rumus ketiga, sama je, kita terbalik je. Okay, ni kan mass over volume. So maknanya mol. Okay, M mol over volume. Okay, so now kita rearrange je. Okay, rearrange. So that volume sama dengan mol over molarity. Okay. So now, next, what should we do? Okay, kita dah ada diberi apa information kat sini. Kita ada mol. Okay, we are given the mol. Okay, we are given the number of, we are given the molarity. So dapatlah kita solve volume. Ni, volume. Okay, ni. Okay, so the answer is 5 liter. Okay, 5 liter. How about this? Example 5. How many grams of copper sulfate, okay, needed to prepare 250 ml of 1 molar copper sulfate? So you are given the molar mass, molar mass. So dia nak gram. Okay, gram. So look at the information given. Kita ada volume kat sini. Kita ada molarity. So what is the first step? Kita buat apa dulu?
The molar formula.
Yes, the molarity formula, which is mol per liter. Okay, so kita ada molarity 1. Okay, kita ada mass liter 250 ml. Kerana ini mil, what should we do first? Look at
Change
this
to
unit.
liter.
We have to change to liter. Okay, so become 0.25 liter. Okay, so from here we solve mol. So kita akan dapat mol. Next, second formula tadi. Number of mole. Mass over
Molar mass.
molar mass. So, mole yang kita dapat sini, substitute here. Substitute the molar mass of copper sulfate here. So, we should be able to solve for mass, which is referring to gram. Okay. So, let us see dia punya answer. Okay. 39.9 gram. Next. How about this? How to solve this? We have sodium chloride here. Sodium chloride mass is 117 gram. We have the volume here. Okay. So what is the concentration? M. So given the molar mass here. Sini. So how to solve this? First of all, kita pakai rumus yang kedua. N tadi. Okay. Mass over molar mass. So masukkan 117. Molar mass 58.5 gram per mole. So kita akan dapat mole here. Okay. Go to the second formula. Okay. Mole over volume. Okay. So volume here 1 liter. Okay. 1 liter. This one, substitute here. We should able to solve for molarity. So let us see what is the answer. Okay. 2 molar. Ni dah bagi jawapan dah. Okay. So 294 gram of sulfuric acid, okay, dissolved in 1 liter of water, will produce what concentration? Okay, given the molar mass here is 98 gram per mole. Okay, similarly like example 6 just now, we find the number of mole first. Okay, so it's been calculated for you here. Number of mole dapatlah 3. Okay, mass ni, mass bahagi molar mass. Okay, dapat 3. Substitute this in the second formula. Okay, for molarity. Given a volume, so dapatlah dia punya molarity. So, 3 molar. Okay, ada soalan on molarity?
Ada.
Tak ada. Okay, so 2 formula tu je kena hafal. Okay. Normally in exam, we will not give you the formula. So, you have to memorize. Okay. So, you just substitute whatever information given in the question, okay, to solve for the problem. Okay, one of the learning objective. Okay, moving on next is formality. So, formality is abbreviated with the capital letter F. Okay, F. Okay, so formula unit will the definition is similar like molarity, but it is regardless of the chemical form. Okay. So this unit of concentration normally describe how to make a solution, but not what exists at equilibrium. Okay. So what does it mean here? Okay, bagi contoh. Okay. So the difference is that, okay, when we talk about a compound that undergo ionization, contoh tadi sodium chloride, okay, semua ionic compound, okay, or salt compound, okay, ionized in water. Ionized mean dia form ion. Itu masuk ionized. Okay. Normally, semua ionic compound means if you look at the periodic table, dia ada komponen yang metal dengan non-metal. So, ini metal, ini non-metal. Okay. So, metal and non-metal produces ionic compound. Ionic compound ionized in water. Okay. So, it produces this ion here. Now, it would not give any how to say very clear different if it involve a ratio of 1:1. Tengok ini satu, ini satu. Okay. However, kalau dia involve ratio yang berbeza, it will give you different in term of molarity and formality. So let's say if I have sodium chloride tadi, so 1 molarity sama je dengan 1 formality. Okay, sama. But let us look at calcium nitrate here. Okay, calcium nitrate. So 1 formality of calcium nitrate would be equal to 2 molarity of nitrate or 1 molarity of calcium 2 plus. Salah ni. 2 plus. Okay. So what it means here, kalau saya tulis calcium nitrate kat sini, okay. So it will ionize into calcium 2 plus and also nitrate 3 minus. Remember stoichiometrically tadi yang saya cakap in my earlier slide, the first slide, balance, kena balance. Kat sini nitrate ada 2. So 2. Okay, nitrate ada 2. So kena balance. So you see, when we talk about molarity, so kita ada 2 molarity of nitrate. 1 molarity of calcium. But when we talk about the whole compound itself, okay, the whole compound itself, so it refers to 1 formula. 1 formality, sorry. 1 formality. Okay, so itu bezanya. If it involve this kind of compound. Kalau dia macam ni, dia tak nampak sangat. Still the same. Okay, so itu maksud formality. Okay, dia tak kisah solution to undergo ionization ke tak. So, itu formality. But molarity, okay, normally dia look at the ionization part. Okay, faham formality? Boleh follow? By definition sebenarnya, by definition, kita tak, 1 molar ni sebenarnya refer to 1 molarity, 1 mole of sodium plus and 1 mole of chloride ion. Sepatutnya macam ni. Kalau kita nak kata sodium chloride, in term of molarity dia kosong. Because why? It fully ionized into sodium and chloride. No longer sodium chloride exists. So if we talk about the whole compound itself, molarity dia kosong molar. Okay. But in analytical chemistry, kalau awak nampak 1 molar ni, 1 molar sodium chloride, sebenarnya by definition awak kena faham dia sodium and chloride lah. Okay. Kita tak akan tulis dia kosong molar lah. Okay. Ada soalan? Before I move on to normality.
So, madam, I have a question.
Yeah.
So maksudnya like kalau the calcium nitrate, so we have to mention both the nitrate and the calcium mole. Do we have to like to mention both of the mole of both concentration?
The mole of what? Both?
Both compound, like the nitrate and the calcium ion.
Oh, okay. Tak perlu. Tapi awak kena faham. Okay. So, kalau awak nampak dalam mana-mana teks, kalau dia tulis 1 molar, okay, 1 molar calcium nitrate, so it's understood. It's actually referring, okay, to the 1 molar of calcium and then 2 molar of nitrate. Okay. Dia macam tu lah. But then, kalau awak nampak 1 molar ni, okay, by right, dia individual ion. Okay. Tapi in analytical chemistry, they normally only written as this. So, understood that it actually exists as calcium and nitrate individually. Okay, cuma the way they write it is normally in one compound macam ni. Okay,
One
unless
more.
the question is asking on the definition, then I can explain lah.
Is it 1 molar or is it one formality?
This is 1 molar. Okay, 1 molar. Okay.
Okay.
Ada soalan lain? Tak ada? If no question, we move on to the next concentration, which is normality, capitalized N. So the definition of normality will be based on the number of equivalent of solute per liter of solution. So it depends on the equivalent of solute. Okay. Now this equivalent depends on the type of reaction. Okay. So normality depends on equivalent of solute per liter of solution, and this equivalent will depend on the type of reaction. Okay. For example, okay, if we look at acid-base reaction, okay, tindak balas acid dan base, okay, one equivalent equals to 1 mole of hydrogen ion or 1 mole of hydroxide ion donated. So dalam tindak balas acid-base, selalunya acid donate electron, hydrogen, donate hydrogen, H+, okay, proton, base accept the donated proton. Okay, so equivalent will depends on the number of mole of proton donated or proton accepted. Okay, so yang ini sama dengan hydroxide ion lah. Okay, hydroxide ion dia donate, okay, or apa tu, accepted, sama. So next type of reaction is redox reaction. Okay, oxidation reduction reaction. So equivalent will depend on the mole of electron take place in this redox reaction. Okay, and then the third type of reaction is electrolyte concentration. So one equivalent will be equal to mole of charge. Okay, so let us look in detail each of this reaction. Ada tak contoh? Tak ada. Okay. Inilah, okay. So contoh kat sini the normality of hydrochloric acid, okay, would be the same as the molarity of hydrochloric acid. Okay, because there is 1 mole of H plus proton ion for every 1 mole of HCl. So HCl, okay, kalau di dissociate, you have H plus and Cl minus. So dia ada satu proton that can be donated. Okay, so we can say 1 mole of proton ion, okay, is the equivalent number. Okay, so the normality of hydrochloric acid will be the same as molarity. Okay, so if I report 1 molar hydrochloric acid, sama juga dengan 1 normality hydrochloric acid. Okay. Now, the difference comes in kalau stoichiometrically they are different. Sama juga macam formality tadi. Okay. Now let us look at example here, sulfuric acid. H2SO4. So H2SO4, kalau dissociate, you have H plus ada 2 dengan SO4 2 minus. Okay. So you have 2 proton here. Okay, which can be donated. Okay, so when we write in term of normality and also molarity, dari sini kita akan nampak beza dia. Okay. So number of equivalent here, 2 kan? Okay, 2. That is for normality. So maknanya it will be twice, okay, twice for the normality compared to the molarity. Sebab ada 2 ni can be donated. So if we write, kita akan buat macam ni. 1 molar sulfuric acid will be equivalent to 2 normality of H2SO4. Faham?
So it depends on the proton.
Yes. Depends on number of equivalent. If you go back to the definition tadi, okay, ni equivalent, okay. So for acid, okay, dia hydrogen ion donated. Okay, kalau dia redox reaction, dia akan depends on electron pula. Okay, formula dia ini. Normality is number of equivalent of solute per liter of solution. So therefore, tadi dia ada 2 kan? 2 equivalent. Okay, 2 mole of hydrogen ion tadi. In 1 liter. So that's why awak dapat 2 normality. Okay. So 2 normality ini sama dengan 1 molarity for sulfuric acid. Okay. The advantage of using normality is awak akan dapat tengok perbezaan in term of dia punya strength. Okay, the acidity strength. Okay. For example, kalau kita report 3 molar sulfuric acid, okay, it will be twice as acidic as 3 molar hydrochloric acid. Nampak macam sama. One is sulfuric acid, one is hydrochloric acid. Tapi if we label in term of normality, we will label as 6N and 3N. Ini for HCl, ini for H2SO4 tadi. Okay. So ini 3N, ini 6N. Sebab dia ada 2 mole of proton that can be donated. Okay. Ini satu je. So if we label using normality, we can see that in terms of strength, this one is more concentrated, okay, lebih berasid daripada hydrochloric acid. If we report as 3 molar of hydrochloric acid and 3 molar sulfuric acid, nampak macam sama je in terms of acidity. Betul tak?
Yeah.
So if we label using normality, kita akan nampak perbezaan in terms of the acidity strength. So that is the advantage of using normality. But not to worry so much. Selalunya kalau dalam integral chemistry, throughout awak akan see common usage of molarity lah. Okay, memang tak adalah normality dengan formality ni. Okay. Unless you work as chemist. Then you have to go in depth lah normality dengan formality ni. Okay. Ada soalan on ni tadi, normality? Kalau tak ada soalan, I proceed with the last part. Kita sampai molality lah. Okay. So molality bunyi macam molarity. Okay, bezanya dekat sini ni. Okay, the difference is here. Okay, molality. So instead of using capitalized M, we use small letter m. Okay, so that represent molarity. So the difference only in the denominator yang kat bawah. Okay, instead of using per liter of solution, we use kilogram of solvent. Okay, the nominator is still the same. Okay, mole of solute. So that is molality. So example, say what is the not molarity, molality. What is the molality of 6 moles of X dissolved into 2 grams of methanol? Okay, go back to the definition. Okay, molal, kita tulis molal lah biasanya. Okay, molality. Okay, similar to mole of solute per kilogram of solvent. Okay. So here we have 6. Okay. So we have 200 gram substitute je. What do we need to do first is convert gram here into kilogram
Kilo.
first. At 30 molal. So I stop here. Okay, nanti saya akan sambung parts per million ni in my pre-recorded lecture lah. Okay.